This video is about the mainly used valve train designs: OHV, SOHC, DOHC, and flathead. An overhead valve engine, also known as an I-head, is common in trucks and tractors because these engines produce higher torque. In this engine, the valves are located in the engine block, but the valve mechanism is operated by pushrods. This engine type allows a more compact cylinder head because the camshaft is located in the middle of the engine. Overhead valve engines are generally less expensive to produce compared to overhead camshaft engines as they have a simpler valve train. Overhead valve engines are known for their high torque output, particularly at lower RPMs. This makes them suitable for applications that need low-end power. The disadvantages of OHV are that the pushrod mechanism limits the maximum RPM capability. The design of the valve train may limit the breathing efficiency, which impacts its performance. An OHV engine has two types: a single overhead camshaft and a dual overhead camshaft. In a single overhead camshaft engine, a single camshaft is responsible for operating both the intake and exhaust valves. These engines are used in mainstream vehicles. These engines provide good balance between performance and efficiency and cost-effectiveness. It is a simpler and more cost-effective version of dual overhead camshaft. The Soch has less moving parts, hence it's easier to repair. The benefits of the overhead camshaft setup is that it allows for more valves per cylinder, meaning that air, fuel and exhaust can move more freely through the engine, adding power, but more power means more fuel consumption. So if talking about fuel efficiency, single overhead camshaft wins. The disadvantages of single overhead camshaft are: the camshaft is placed in the head, denying the spark plug from its ideal location. Single overhead camshaft have less control over valve timing compared to Doch. In the Soch, a single camshaft is controlling both the intake and exhaust, thus this engine gain heat faster than a dual overhead camshaft. In a dual overhead camshaft, there are two camshafts per bank of cylinders. In a dual overhead camshaft engine, one camshaft is dedicated to operate the intake valve and the other is to operate the exhaust valves. In an inline engine, there are two camshafts, while in a AV or a boxer there are four camshafts. Advantages of dual overhead camshaft: by having 4 valves per cylinder instead of 2 allows for a larger portion of the area can be used to let the air and fuel mixture in and let the exhaust out it. The engine can make more power if more air enters the cylinder and waste less power if it's easier to pump air and fuel into the cylinder. As her engine speeds, the engine pumps a lot of air through the cylinders, having 4 valves per cylinder. By having 4 valves per cylinder instead of in a flathead or a side valve engine, the valves are located in the engine block. Flathead engines were widely used in the early to mid-20th century, however, they have been largely replaced by overhead valve engines. Due to the limitations, flathead engines were known for their simplicity and their low manufacturing cost. However, they did have certain limitations in terms of combustion efficiency and performance. Flathead engines includes a camshaft located low in the cylinder block. This camshaft operates the poppet valves, trough tappets, and short pushrods. The flathead design doesn't need additional valve train components, such as rocker arms. In the L-head version, the valves position adjacent to each other on one side of the cylinder. On the other hand, a rare configuration called a T-head uses 2 camshafts to drive one valve on the left side on the cylinder and the other of the right side of the cylinder. The spark plug is located above the piston or above the valves. One of the main problems of the flathead are the limited airflow and out the combustion chamber, leading to less efficiency. The flathead design also has limited the compression ratio.